is John from caveofprogramming.com. In this tutorial we're going to take a look at creating particles represented by pixels that we can plot on our screen. So at the moment I've got this window which just displays a block of colour and slowly cycles through different possible colours. So I'm going to use that later on. I'm going to save that code for a while, but what I want to do now is define a particle class and display those particles on the screen. So let's go to Eclipse and let's create a new class here. So I'll right click the project, go to new class, and I'll call this particle, and I'll keep it in this Cave of Programming namespace. I don't know if I'll need a constructor and destructor, but let's define them because there's certainly no harm in having them. Let's click Finish. I'm also going to define another class here which I'm going to call Swarm, and Swarm is going to manage a collection of particles. So let's, again, I'll give it a constructor and destructor. I'll call it Swarm and put it in this Cave of Programming namespace again. So we've got two new classes here. Now let's go to particle and let's start thinking about what kind of properties a particle will have. So we're going to define some private instance variables here. And I suppose the most fundamental thing about the state of a particle is that it needs an X and Y position on the screen. And now I'm going to make these double, so let's say double, and I'll call this m_x, m to say that it's a member variable, just to make that clear, although that's certainly not absolutely necessary. And let's have a double m_y. Now the reason I'm making them double is because even though on the screen we're dealing with individual pixels, so the X and Y location are always integers, I want to be able to change these values gradually and then just sort of round them off to the nearest pixel position. So if I want to change, for example, the X value gradually by adding some small number to it, like 0.01, every time the screen refreshes, of course I can't do that if it's an integer. So although we have to display it at kind of an integral position at a particular pixel, its position may be somewhere between two pixels. We just kind of round it off to the nearest pixel when we actually display it. But having a double position allows us to move it conceptually bit by bit. So, and that avoids having to move it by an entire pixel every time we move it. So we can achieve more of an illusion of smooth movement. So we've got X and Y. That's probably all we really need to start with. Just an X and Y position for the particle, as far as I can think at the moment. Let's go to the particle constructor here, and in the constructor I could initialize the X and Y values, really. So yeah, let's maybe do that. What I'm going to do is I'm going to include standardlib.h, because I want to use a function called rand, like that. And rand returns a random number between 0 and a constant called rand_max. So this returns an integer, and this is an integer, I believe. So this division wouldn't really make any sense. But if I multiply rand by a double, or if I cast it to a double like that, this will then return as a random number between 0 and 1. Now, what I'd really like to do is I'd like to have the particles kind of move within some virtual space, but I don't want that virtual space to be tied to the screen dimensions, because then if I change the size of the screen or something, then the way our program works has fundamentally changed. I want to have the particles move around in some space of a fixed size, some mathematical space, and then we'll map that later onto the screen. So I'm going to initialize the x position of the particle to somewhere between, let's say arbitrarily, -1 to +1. So we can imagine that the particle inhabits a plane with Cartesian coordinates, if you've ever done any maths, where the minimum x and y coordinates are both -1 and the maximum possible x and y coordinates are both +1. And if you've never studied Cartesian coordinates, you might want to just have a look at a page on them, just for sort of 10 minutes or something, just to get the idea, but they're relatively simple. So if I set, this is going to set x equal to something from 0 to 1, but I want it to be from -1 to +1. So let's firstly maybe work on the range there. So if I multiply rand by 2.0, so now we don't need the Castler double because this bit is a double now. We could put brackets around that just to be doubly sure, so to speak. So this should give us a number in the range 0 to plus 2.0. And if I then subtract 1 from that, I think I'm right in saying that we've now got a range of -1 to +1. So firstly I increased the range there, so that instead of being 0 to 1 it was 0 to 2. Then I subtracted 1, which gives us -1 to +1, if I've got this correct. What's the warning there? Bad character sequence. Sometimes I find this happens, and I think I'm somehow typing invisible characters that it doesn't like. I'm not sure how, but yeah, that's fixed that. I just had to delete, sort of underlined a space there, and I just had to delete it and put the space back in again. Maybe I hit the Alt key by mistake or something, but it doesn't seem to stop it compiling though. Let's do the same with y as well. So let's set y equal to some random number from -1 to +1. So that's our particle covered. Now usually what I'd do is I would supply like a get method for x and y, but we're going to have to deal with a lot of particles, and we're going to have to get x and y values over and over again every time the screen refreshes for a huge number of particles. So perhaps it's better to simply make these values public and access them directly. That breaks encapsulation, but we're forced in games and simulations and things like that often to adopt a programming style that's not ideal for the sake of efficiency. So it might be better to make this public. An alternative thing that you often see done is, instead of explicitly declaring this as public, what we could do is, by default in a class, if I write it like this, these will be private by default. But there's also a thing called a struct in C++. And if I just change this from a class to a struct, the only difference between a class and a struct is that the members are public by default. So if I do this, then we know that the intention is to access these directly and that they are now public. So maybe I'll do that. So that's the only difference between a class and a struct, and that's the sort of thing they ask you on interviews as well, is that by default in a class, member variables are private if you don't specify an access modifier. In a struct, they're public by default. And I'm just making them public for the sake of efficiency, although ideally we wouldn't do that. So that's my particle covered. I also need to initialize this random number generator, because I think it returns, as far as I know, it returns the same random numbers in sequence every time, and I'd like it to return different ones every time. And we can do that by going, for example, to main here, and if I include here, include standard lib again, standardlib.h, and using namespace standard. I've missed out there, D there. then I can call a function here called srand. And srand seeds the random number generator with a number, which makes it produce a different sequence of random numbers every time. And for the seed number, because I need to supply it with some number to seed it with, I can use a function called time, which is found in time.h, I think, but it's probably already included because we've got stl.h. There's no harm in including time.h if it exists. It does kind of change its name from implementation to implementation. Let's just check what the error is here. So there's something there it doesn't like. I'm just going to check the program that I implemented previously in case I've got this slightly wrong somehow. Let's just check where I seeded my time. So somewhere in here I should have seeded my random number generator. Oh yes, there we go. Ah yes, so the time function takes null. It can return the time into a struct that you pass it, if I remember rightly, and this might be wrong, so don't take this as gospel. But we don't want it to do that. We don't want it to return anything other than the number of milliseconds, I think it is, since 1974 or whatever it is, something like that. To be honest, this is one thing that I've got so used to typing that I've stopped wondering what it actually does. Let's close some of these, null, but you can certainly Google for that if you're interested. But basically this formula here seeds our random number generator. Okay, so let's leave that and go back to our program. Okay, I'm going to close everything actually so that I don't get confused and open them again here. So that's not even a right program. Here we go. So particle.h. Okay, so we've got our particle now, and now I want a class that organizes the particles, because we're going to have to deal with a massive load of particles, and I'd like some class that can organize them all. So I've got my swarm here that I've created, and I'm going to give this a private member variable here. Let's say that it's, well, if I include here, if I include double quotes because it's a local include file, particle.h, and I'm using this Kava programming namespace, and then I can say in here particle pointer, let's call this m_p particles, m because it's an instance variable, p because it's a pointer. Then in my constructor here, let's go to swarm.cpp. Probably this is a reasonable place to initialize this. Let's set that equal to new particle array. And how many particles do we want? Well, I can define a constant. Let's call the constant n particles. And let's go to swarm.h and make that I'll make it public just in case we need to use it outside of swarm. Yes, we probably will in fact. Let's say n particles, and let's make that a const static int. And set it equal to some number like 5,000. You might want to make this lower if your computer's a bit slow, but if it is, you'll find that out later on. But let's try 5,000 to start with. So we're going to have 5,000 different particles. And now we mustn't forget in swarm.cpp, in the destructor here, we have to delete m_p particles. And because it's an array, we need these square brackets. So m_p particles. So now we've got a load of particles there. So this is going to allocate memory and also fill that memory with a bunch of particle objects. And when the particle constructor for each particle runs, it's going to assign a different random location to itself. Now I also want to be able to get particles from my swarm. So I'm going to go to swarm.h here and create a public method which returns a particle pointer, and we'll call it, I could call it get particles, or even just particles. Sometimes it's nice to omit the get, but perhaps get particles would be clearer. Let's call it get particles, and I'll actually implement it here in line because it's only going to be a small function, so I'll implement it in the header, and we'll just say return underscore p particles. Now we should think about const a bit here. This particles pointer, we don't want to point it to anywhere else ever. Once we've set it equal to something in our constructor. So why not make it a const pointer to a particle? And when we actually return it, we want to make sure that when we actually get this pointer outside of this class, we want to make sure that the particles that it points at can't be changed. We only want to change them possibly within this class or within the particle class itself. So let's say that this returns a const pointer, in other words a pointer that can't be made to point anywhere else, to a particle that's const. So a const pointer to a particle that's const. So the particle can't be changed either using this pointer that's returned. Let's try that. Let's just build this thing and see if it builds. So I've got an error here. Oh yes, because I signed this in the constructor. Maybe I can't really make it const because I have to change it at least here. So yeah, that's a shame, but I don't really see a clear way around that. So let's get rid of this const actually. Because sorry, not that one, this one, because otherwise we can't even assign it in the constructor. Okay, let's try this. So I think that looks good. Now let's see if we can actually draw these particles. So let's go to main.cpp, and in main.cpp I'm going to declare a swarm somewhere here. Let's declare a swarm. I'll call it swarm, so that the class has an uppercase S. That's the convention I'm following, and I'll make the actual object the same name with a lowercase s. Some people hate this convention, but I quite like it. We've only got one swarm here, and my classes all have an uppercase letter, so the object can just have a lowercase letter there. Then in my while loop here, I need to get a pointer to all the particles I want to draw. Before I do that, let's comment out some code here. Let's comment out the stuff that displays that puts the coloured block on the screen. We're going to use that later, so I'll just comment it out for the moment with a multi-line comment here, /*// and we'll use it later. Now that should hopefully give us a black screen, and hopefully it shouldn't crash or anything. Let's not continue because we've got an error there. So I've got unused variable elapsed, but that's just a warning. We could include that in the comment. We've also got a error unknown type swarm, and that's just because I forgot the header. So let's include here swarm.h. And let's try building it again, see if it builds this time. Whoops, build project. And yeah, it looks fine now. Let's run it, and we get a nice black screen. Okay. So now let's see if we can plot that collection of particles with their random positions. So they won't move at the moment. We can maybe do that in the next tutorial. Quite exciting, but we can at least plot them so we have something that looks like sort of like stars. So what we need to do is we need to loop through all the particles. Let's say for int I equals 0,